Hey guys! I'm super excited to dive into something that's always fascinated me. The computer programming process. You know, it's like building a rocket, but instead of physical components, we're dealing with lines of code. So check this out. We're going to break down this process step by step, and I promise you, it's going to be really cool. Alright, so the first step in our programming journey is planning and analysis. This is where we really get our hands dirty with understanding the problem we're trying to solve. It's like, when you're building a rocket, you gotta know exactly what kind of mission it's going on, right? Same thing here. We're gathering requirements, talking to stakeholders, and basically laying out a roadmap for our software. Now, let me tell you something important. If we mess up this phase, it's like building a rocket with the wrong specs. You know what happens then? Boom! Your software ends up not doing what it's supposed to do. So we gotta be really careful here, guys. Okay, now we're moving on to the design phase. This is where things start to get really interesting. We're basically creating the blueprint for our software, just like engineers do for rockets. We're mapping out the high-level structure, figuring out how data's gonna flow through the system, and even sketching out what the user interface might look like. But, you gotta listen to this. If we don't do this right, we're in for a world of hurt later on. It's like, if you design a rocket without considering aerodynamics, you might end up with something that looks cool but performs terribly. Same with software. Poor design can lead to a system that's a nightmare to implement, scale, or maintain. And don't even get me started on the security vulnerabilities that can pop up. It's crucial to get this phase right, guys. Now we're getting to the part that most people think of when they hear programming, the actual coding. This is where we take our design and turn it into something a computer can understand and execute. It's like, you know when you're assembling a rocket and you're putting all the components together. That's what we're doing here, but with lines of code instead of physical parts. But, listen up. Writing good code is an art form. It's not just about making it work, it's about making it work efficiently and elegantly. If we're not careful, we can end up with code that's full of bugs, inefficient, or just plain hard to understand. And let me tell you, trying to fix badly written code later on is like trying to rewire a rocket mid-flight. It's possible, but it's going to be a real pain in the neck. Alright, so we've got our code written. We're done, right? Wrong! Now comes one of the most critical phases, testing. This is where we put our software through its paces to make sure it does what it's supposed to do. We're talking unit testing, integration testing, system testing, the works. It's like when you're testing a rocket on the ground before launch. You want to catch any issues before they become real problems. Now, I can't stress enough how important this phase is. Skimping on testing is like, deciding to skip the pre-flight checks on a rocket. Sure, you might save some time, but the potential consequences are just not worth it. So, we've planned, designed, coded, and tested our software. Now it's time for integration and deployment. This is where we take our shiny new software and get it working with existing systems. It's kinda like when you're integrating a new component into an existing rocket design. You gotta make sure everything plays nice together. But, you know what? This phase can be tricky. Poor integration can cause all sorts of disruptions to existing systems. And if we mess up the deployment, well, that can lead to errors in the software environment that can really mess with performance and usability. It's crucial to handle this phase carefully, making sure all the pieces fit together just right, like the components of a well-designed rocket. Alright, last but definitely not least, we've got maintenance. Now, a lot of people think once the software is deployed, that's it. But that's not true at all. Software needs regular updates and maintenance, just like how rockets need regular checkups and upgrades. We're talking about fixing bugs, improving performance, and making sure the software keeps up with changing user needs. Neglecting maintenance is like, never servicing your rocket. Sure, it might fly fine for a while, but eventually things are going to start breaking down. Trust me, guys, you don't want that to happen. Now, let's circle back to something really important in the planning and analysis phase: stakeholder input and resource management. You know, it's not just about understanding the technical requirements. We need to talk to the people who'll actually be using the software, understand their needs, their pain points. It's like when designing a rocket, you gotta talk to the astronauts who'll be flying in it, right? So, let's talk about something crucial in the design phase: scalability. When we're designing software, we're not just thinking about what it needs to do now, but what it might need to do in the future. It's like designing a rocket that can be easily upgraded for future missions. We gotta plan for growth, guys. Let's wrap up by talking about two super important concepts: automated testing and technical debt. Automated testing is like having a robot that can run through all your pre-flight checks on a rocket. It's faster, more reliable, and can catch things humans might miss. And technical debt? Well, that's what happens when we take shortcuts in our code. It's like using duct tape on a rocket. It might work for now, but it's gonna cause problems down the line. And there you have it, guys. That's the computer programming process in a nutshell. It's a complex journey, full of challenges and exciting discoveries. Each phase is crucial, building on the last to create software that's robust, efficient, and effective. Just like building a rocket, it takes careful planning, precise execution, and constant vigilance. But when it all comes together, man, there's nothing quite like it. Keep exploring, keep learning, and who knows? Maybe you'll be the one to write the next piece of software that changes the world.